In today's video, here is a nice function equation. Here is the following setup for all f as an application from r plus to r, which means from the positive real numbers to the real numbers, which is verifying this following equation. We get f of x plus y equals f of x is multiplied by f of y minus xy for all x as a positive real numbers. So our goal, we are going to find all functions which is verifying this condition. Okay, before we get started, obviously you can test a few values of y and x in order to make the equation in terms of x or y, and then you will find a reduced equation, or you can extract a few equations then combine them each other in order to get a final one. Okay, now let's see. You guys, you can give the hands to Spram pre-record solution. Go ahead, pause the video when you are, you come back to see the full solution. By the way, don't forget to hit the subscribe button and support the channel. Okay. Now let's jump into the solution. So obviously it seems if I'm going to give y equals 1, I will have a nice thing here. So I get the following equation. I get f of x plus 1, which equals f of x is multiplied by f of 1 minus x. Okay, now I get the equation in terms of x. Now I'm going to give x equals x plus number 1. So I get x plus number 1. So I get f of x plus 2, which equals f of x plus number 1 is multiplied by f of 1 minus x minus number 1, because I'm giving x equals x plus number 1. By the minus sign, everything becomes negative there. Okay, now I have two equations. This equation number 1, I get equation number 2. I'm going to insert the equation number 1 into the equation number 2 by replacing f of x plus number 1 by its value. So I get f of x plus 2. I'm working on the equation number 2, which equals f of x plus number 1 is going to take this value, which is f of x is multiplied by f of 1 minus x, all is multiplied by f of 1 minus x minus number 1. This is the equation number 3. What to do here? Now what to do here? I'm going to go back to the original equation and replace it, and replace y with number 2 here. Okay, so I get y equals 2, because I'm going to find another equation which is containing x plus number 2, which I'm going to use here. F of x plus 2, which equals f of x is multiplied by f of 2 minus 2x. Let's call this equation as an equation number 3. Let's call this equation as an equation number 4. So since we get f of x plus number 2 in two equations, I'm going to get rid of this one and leave the function is involving just f of x. Okay, so it's more simple here. So I get f of x is multiplied by f of 2 minus 2x, which equals f of x is multiplied by f of 1 minus x, all is multiplied by f of 1 minus x minus number 1. Okay, it's more clear. So in this case, I'm going to pull out f of x, put it on one side, and so I get the following. So I get here f of x, which is going to be multiplied by f of 2, then moving over this one, but this one is multiplied by f of 1, and this f of 1, which is f of 1 square. By taking it to the other side, you will change the sign to minus sign. Okay, so I get minus f of 1 square, and move over everything to one side, which is the right side. So I get here 2x, This one it will be multiplied by minus x, so I get minus x is multiplied by f of 1 minus x minus number 1. So this one is going to be reduced to x minus x, which is x minus x f of 1 minus number 1. Let's say replace x with number 1 here. So x with number 1, so I get here f of 1 is multiplied by f of 2 minus f of 1 square, which equals 1 minus f of 1 minus number 1. So I will have some cancellation here, so this one is going to be cancelled out with this one. So now I'm going to divide both sides by f of 1, but be careful here. If f of 1 different than 0 implies these things, which is f of 2 minus f of 1 square equals minus number 1, because I'm dividing both sides by f of 1. Okay, so let's move over this f of 1 square to the other side and bring the minus number 1 to the left side. So I get the following: I get f of 1 square, which equals f of 2 plus number 1. Okay, so I get to this important formula. Let's call it as an equation 5. So but remember, if f of 1 different than 0, we will have this one. But what about if f of 1 equals 0? Prove f of 1 cannot be 0. So we are going to do that by the way of contradiction. Let's assume f of 1 equals 0. What's going to happen to this equation? So by the way of contradiction, suppose f of 1 equals 0. So I'm simply going to use the first equation and extracting f of x. So I will have f of x equals f of x plus 1 plus x divided by f of 1. Okay, so I will have here f of x, which equals f of x plus number 1 plus x is divided by f of 1, like this. Okay, in order to have f of x exist, which means f of 1 must be different than 0. f of 1 different than 0. Otherwise we won't have, otherwise f of x is not going to be exist if f of 1 equals 0, because f of 1 is located in denominator. Okay, this one, it's clearly it's a contradiction, because we have considered f of 1 equals 0, but we have arrived, but we are concluded it's impossible to be f of 1 equals 0, because if f of 1 equals 0, which means this function is not going to be exist. Okay, f of x. So it's clearly f of 1 equals f of 1 different than 0 is a correct one. Okay, now let's get rid of this one and find a function. Now we have arrived to the point where we can find the function. Okay, so what to do in this case, since we know the relationship between f of 1, since we know this formula, so I'm going to take advantage over this one and use it in the previous equations in order to find f of x. Okay, let's replace in f of 2 with f of 1 square minus number 1 here. So I get the following: I get f of x, f of 2 is going to be replaced with f of 1 square plus number 1 minus f of 1 square. Okay, I'm taking this one and insert it back here, which equals these things, which equals x minus x f of 1 minus number 1. Okay, so I have this equation now. So what to do with this equation? I'm going to pull out f of x. So I will have some cancellation here. This one is going to be cancelled out with this one. I will be left with f of x equals x minus x is multiplied by f of 1 minus number 1. So I get f of x, which equals, I get here, let's take minus sign out of these things. I get minus, so I get here, let's take x as a common factor. So I get x factor 1 minus f of 1 minus number 1. Let's take this minus sign out of these things. I get minus here like this. So I'm going to replace this one with a. So we'll have, so with this a, it can be positive, it can be negative. We are going to neglect this minus sign. So I get minus ax plus number 1. I'm going to neglect this minus sign because this minus sign is necessary to have minus a. You can have c or b, whatever, because it just is constant, but we are going to find that. Okay, I'm going to use the original equation to find a. Okay, so I get f of minus a factor x plus y equals minus ax plus number 1 factor minus ay plus number 1 minus xy. So I'm going to calculate that. Let's calculate that. So I get minus ax minus ay plus number 1, which equals a square xy minus ax minus ay plus number 1 minus xy. So we'll have a lot of cancellation here. So this one is going to be cancelled out with this one with this one, number 1 with this one, and move over xy to the other side and divide both sides of this equation by xy, since we have xy is strictly superior than 0. Okay, so in the end I get a square equals 1, which means a equals plus or minus number 1. Okay, finally I get the function f of x by replacing this plus or minus 1 with a. Finally I will have f of x equals plus or minus x plus number 1. Okay, this is the final expression of this function, f of x equals plus or minus x plus number 1. So I have done this problem. Thank you for watching. I will see you next video. Bye.